Okay. For side angle side similarity, because it was requested to review this. What we want to do. Frozen's an awesome movie.
A date? You went to see Frozen?
Yes.
We're engaged.
Girls or...
I've seen it 13
Family.
times.
How many?
Entire family.
13.
Yeah.
I saw it too. No.
How many times?
I thought it was cute.
What?
All right.
Every time.
Why have you watched it that many times?
No. I like the snowman. I like fall asleep to it sometimes.
Yeah. Oh, I've been impaled. Okay.
I just think I've been impaled.
Okay. So, for side angle side similarity, what we get is usually a situation like this with the vertical angles. So that's a corresponding congruent angle. But then we have some sides here. Let's say this is 16 and this is 14. And I'll say we got 24 and 21. All right? So those are our lengths. To show side angle side similarity, we show the corresponding angles are congruent because, again, it's side angle side here. We have the corresponding congruent angle. We go ahead and set up our proportion with our corresponding sides to see if the proportion is true. And we can do the proportion either by reducing them both or by cross-multiplying. It doesn't matter which way we do it. But we do have to set it up first. So the question is, if I'm going to go 16 over 14, okay, or actually, let's do 16 and 14. Is the 16 going to correspond to the 24 or the 21? Well, what you have to ask yourself is 16 the longer or the shorter of the two I'm going to be comparing? And 16 is clearly the longer, so longer compares to longer, and shorter to shorter. And I can confirm that that is a true proportion two different ways. I could either reduce both fractions to the same ratio and show they're the same, or I could cross-multiply and show that the products are the same. If I do the reducing method, I'd say 8 goes into 16, 8 goes into 24, that's 2 and 3. And 7 goes into 14 and 21 equals 2/3. That's a true statement. That shows the sides are proportional. So you've proven that the corresponding sides are proportional, and I've got side angle side similarity. If I want to do the cross-multiplying method, that's fine too. I can do 24 times 14 and 16 times 21. All right? And when I take 24 times 14, well, if you're going to do the cross-multiplying, you just go ahead and do it. If you're going to simplify it, then simplify both of them, you're done. Right? 25 times 14 is 336. 16 times 21 is 336. Aha. That, again, that's a different way of proving that they are proportional. So I can do it by cross-multiplying or by reducing. A lot of people prefer the cross-multiplying when it's side-angle side because cross-multiplying is so simple. I mean, a few seconds on your calculator and you're done. Reducing, however, is the only way we can use for side because we can't just cross-multiply when we have three ratios. We have to reduce. We have three ratios. So that's how we do side angle side. And again, it's because it's the angle and the sides. Now we have to be a little careful. If these sides were, say, here, 14 and 21, that would not be side angle side, would it be? That's side angle. And angle side or side angle does not work. It's got to be side angle side. Side angle side, again, kind of reviewing back to side angle side, the angle is between the sides. Just like when I write it out, side angle side similarity, the angle is between the sides, isn't it? When I write it, the angle is between the sides. When I draw it, the angle is between the sides. It has to be consistent. So that's how we do side angle, side similarity. Are there any from the homework that you'd want me to go over specifically? Any of these problems? Okay. Well, let's take a look at a couple things then. Because essentially this is what we're doing again tonight. It's more of the same stuff. I mean, right now, folks, the plan is if we only have to miss one day, Monday, probably not going to change a whole lot with regard to our schedule here. Okay, our exams will still be at the same time. Everything's fine. If we miss 2 days, still probably not going to affect the exam schedule, but it's going to really cramp our review time significantly. And probably what would happen then is our only reviews would be in the afternoon study periods after like the Tuesday exam. You know, we have exams in the morning and then we'd have a review period in the afternoon. Okay?
Oh, we have the learning crap.
Yeah.
I thought we were done learning.
Well, no, it's actually separate. But, like I said, it's old school. I went old school. No.
I'm pretty sure he's Caucasian.
I like I say, I went old school. It's 97. This is how they wore it in 97. So I was there. You weren't.
How do you know? You were? Maybe I was just born.
You were a twinkle in someone's eye still, probably.
Or an egg.
January of 1997?
Maybe was.
I was like,
Okay. So, all right. So, what other things we're going to see? So, we're going to go ahead and just look at the review again. Just a little bit of reviewing stuff, and then we'll basically give you the rest of the period to work on things. But proportions: 3 over 5 equals x plus 7 over 8. All right. When we have proportions that involve binomials or algebra, or in fact, let's do x plus 7 over 14, just to address an issue here. Start with, I cannot reduce this 7 and the 14. You'll remember that from algebra. I can't cancel parts of polynomials. When you did the unit on rational expressions, this is probably one of the things that was the biggest difficulty for a lot of people. When you had something like 2x plus 5 over x plus 10, a lot of people like to say, oh, 2x cancels the x, the 5 cancels the 10, and start reducing. But we can't do that, can we? We can only cancel factors of polynomials, not parts. And we're never going to have something in geometry where you have to cancel or factor the polynomial on cancel first. I'm not going to have you doing that algebra step. So really, all we're doing is our normal cross multiplying. 3 times 14 equals 5 times x plus 7. And please, as you're doing this, write that out, because you're much less likely to make a distributive property error. Yeah, new year, new lips.
Same one.
No, new lips.
New kidney.
new brain.
Yes. I don't like the color. So this would be 42 equals 5x plus 35. So 7 equals 5x. So x is 7/5. And again, if we get a fraction, the nice thing about these problems is even if we do wind up with a fraction answer, it's usually just the very end that gives us the fraction. We usually don't have to work with the fraction or multiply it or add it or anything like that. It's just the end gives me a fraction. That's okay. 7/5 is a perfectly fine answer. There's nothing wrong with that at all. So that's going to be on there. Things like we had in the first worksheet, the 6.3 worksheet, is setting up and solving proportions with similar figures. So if you are told, for example, actually let's do it this way. Change my mind. Shape. Triangle. Okay. We'll clone it so I'm guaranteed similar. And we'll flip that up down and we'll rotate it. All right. So A, B, C, Q, R, L. Those are my triangles. And let's say we're told that they are similar triangles. So you're told that these triangles are similar. All right? Jake. Zip it. We're told the triangles are similar. And 8, 13, 10, x plus 4. All right? This is the kind of thing that was giving people trouble on the homework that we did just before break. But again, we have to set up our proportion and solve it. That's the only way this works. And sometimes a little tough to tell which side is which, but here it's pretty easy to see that one side is longer than the other. So we go with that. BC is the shortest side. RL is the shortest side. So 8 compares to 10. And then BA is the 13. And RQ corresponds with that, x plus 4. And I could reduce before multiplying, but I could also just multiply. 8 times x plus 4 is 13 times 10. So 8x plus 32 is 130. Subtract the 32. I get 8x equals 98. So x is 49/4 in lowest terms, which is 12 1/4. But that's the kind of problem you can expect to see as well, where you have to set up and solve. Now, that's not asking are the triangles similar, it's telling you the triangles are similar, and then you need to solve the proportion. But most of the work you're going to see is just like what we had on the worksheet last night, which is, are the triangles similar? Show how, support your answer by showing the math. Don't just write down the similar triangles, write down the reason why, and show the math that proves it. So again, our reasons why are angle-angle similarity, side-angle-side similarity, and side-side-side similarity. I got a present? Okay, Kaylee, get your passport. Yeah. So those are our 3 ways of proving that triangles are similar, and that's what you're going to be working on. And like I say, you'll pretty much have the rest of the period to work. But I'm giving you both worksheets. Make sure you take them home with you, as Mr. Billhorn said. Don't leave stuff here at school and go, oh no, I didn't have it with me. You don't have to carry a big book home with you. You only got to carry the worksheets.
I already have my book at home.
I can tell them what?
That's a lovely idea.
I thought that's what your answer would be.
I got them off 7th grade.
So this is just a regular worksheet that'll be due on Monday.
Oh dear.
I'm not the only one.
Like wrote 12 / 1.
Hold on, I'll give you the pass thing. Seriously. There you go. No.